All right, good to go.
Yes.
All
So,
right.
welcome all. Thanks. I want to start with welcoming everybody for the virtual event for July 2024. Was part of the IMTC call that we conduct. Today we have Nanddeep and Smita, who are going to deliver a topic called Building Copilots with Semantic Kernel for Microsoft 365. And thanks Nanddeep and Smita for accepting to do this. And over to you.
All right, thank you very much, Margo, for that introduction. And firstly, thank you very much, India Microsoft Tech community, for giving us this opportunity, right? So, quickly, we are here to talk about building copilots with semantic kernel for Microsoft 365. I know the title sounds quite big, but don't worry, we will go, or maybe we will bisect that, and then we will be covering um, slowly the topics that we have got there. Okay, so this is what we have today to discuss with you, because as of now, when as today we are speaking, we do have various things which are being covered under Microsoft 365. At the same time, when we are looking out to go ahead and have the AI kind of an functionality being built into the Microsoft 365 apps. So there, most of the time we get encountered against Copilot as well as semantic kernel. So semantic kernel comes very handy whenever you want to go ahead and create your, or maybe give some more kind of an intelligence to your copilots. So this is what we are going to cover today, like using that semantic kernel, how you are going to go ahead and give some more intelligence to your copilot. Okay, but again, we will not directly deep dive into the semantic kernel. We want to give some time. We will get introduced to the open AI as well, Azure open AI specifically. We will get introduced to few of the concepts, and then we will go for semantic kernel and again how you can use that in Microsoft 365. All right, so before we start, quick introduction. Myself, Nanddeep Nachan. I am from Pune, and I'm Microsoft MVP for MP65 as well as AI platform. Author of these three books, including SharePoint Framework, SharePoint Hybrid, as well as Viva Connections. And on to the right hand side, here are few of the social media handles to get in touch with me. And with me today is Smita.
Hello, myself Smita Nachan. I'm a Microsoft MVP as well as I'm author of these two books, and these are some of my social handles by which you can get in touch with me.
All right, so with that, let's get on to the agenda. What we have to cover today. So, as I said, we won't be directly deep diving into the concept of semantic kernel, but we will start from the scratch. We will get introduced to the Azure AI Studio, and then again from there we will see how we can go ahead, create the projects, create a hub, as well as how we can make all those deployment basic things. Then after we will see how we can extend on top of it by using the function calling with the Azure OpenAI service, as well as how we can use this OpenAI Assistant API, which are in preview but they have got good capabilities. Then we will start slowly moving towards the actual topic of the today, which is Copilot stack. There we will understand how the Copilot has been stacked, and again how we will be able to build on top of that so that we can build those AI powered solutions for Microsoft 365 as well as in general. We will see what is meant by semantic kernel, how does it help to do all those things, and then lastly we will end our session by showing some cool demos about how we can build the booking solution. Booking is one of the app which is available inside of Microsoft 365. So we will see how we can build the booking solution with semantic kernel for Microsoft 365. All right. So this is the agenda that we have got. But let's get to the basic. Let's get started with Azure AI Studio. Okay.
So, Azure AI Studio is your all in one AI platform for building, evaluating, and deploying the generative AI solutions and the custom copilots. So, it brings together the capabilities from across the multiple Azure AI services. So, it is a comprehensive platform that empowers developers of all abilities and preferences to innovate with AI and shape the future. So it seamlessly integrates multiple Azure AI services and tools, allowing you to explore, build, test, and deploy AI solutions. So when it's come to the Azure AI Studio, it designed for developers to build generative AI applications on an enterprise grade platform directly from the studio Studio, you can interact with the project code first via the Azure AI SDK and Azure AI CLI. So, the Azure AI Studio is a trusted and inclusive platform that empowers developers of all abilities and preferences to innovate with AI and shape the future. So, seamlessly explore, build, test, and deploy using the cutting edge AI tools and ML models grounded in responsible AI practices. So, build together as a one team. Your Azure AI resource provides the enterprise grade security and collaborative environment with shared files and connections to pre trained models, data, and compute. So, organize your way. Your project helps you to save the state, allowing you to iterate from the first idea to first prototype and then first production deployment. Also, easily invite others to collaborate along this journey. So, with Azure AI Studio, you can evaluate large language model, that is the LLM responses, and orchestrate the prompt application components with the prompt flow for better performance. The platform facilitates the scalability for transforming proof of concept into the full fledged production, and also continuous monitoring and refinement support long term success. So, some of the key features of Azure AI Studio, the first one is the Generative AI Development Hub. So, Azure AI Studio serves as a hub for creating, evaluating, and deploying the generative AI solutions. So, whether you are a seasoned developer or just starting out, you can leverage the cutting edge AI tools and the machine learning models within this platform. The second one, it is a responsible AI practices. So, grounded in responsible AI practices, Azure AI Studio ensures that your AI solutions are the trustworthy as well as they are ethical. So you can build with the confidence knowing that the platform emphasizes transparency, fairness and accountability. The third one for the custom copilots. So the Azure AI Studio allows you to create a custom copilot, and this copilot can assist you in various tasks such as natural language processing, recommendation systems, and many more things. So you can tailor them to your specific needs and integrate them seamlessly into your application. So the fourth key feature is a built-in security and compliance. So Microsoft invests heavily in cybersecurity, allowing USD 20 billions to enhance the security and the compliance. With that, now let's go ahead with the demo.
Alright, so now that we have a basic understanding of what is meant by Azure AI and again what is meant by Azure AI Studio, so let's get into the demo and see how we can go ahead and start using this Azure AI Studio. For that, let me go to the Azure portal, portal.azure.com. This is the place from where we start creating resources inside of Microsoft Azure. Azure OpenAI is again one of the resources that you will be able to create in Microsoft Azure. Even as of today, when we talk, Azure Open AI is not available for everyone as a general, but you need to ask for the request. Microsoft do approve that. For example, if you are providing the valid reasons why you want to go ahead and create this Azure resource, and then you're good to go and create those Azure resources. So this is how it looks like. So right now you can see that I have created this Azure Open AI resource into the East US location, and again these are the endpoints that I have got. Now that when it comes to using this Azure OpenAI as a resource inside of Azure portal or maybe in general, there are various ways which are available. So the first thing that we have got here is you can go ahead and start using this Azure OpenAI Studio, which is here. So this is a studio that was already available when Azure OpenAI was launched into the Azure portal. So this is kind of an studio which will look something like this. Even as of today, we do use those, but now that we do have something called as an Azure AI Studio, okay, so which we will be mostly focusing on. But let's quickly see how this Azure Open AI Studio looks like. So which one has got a basic kind of functionalities. So onto the left hand side here, you can see that we do have a management section wherein we'll be able to see all of the models that we have got available for this Azure OpenAI resource. One more thing is, since as I mentioned, like this Azure OpenAI resource is created into the East US 2 region. So based on where you are creating that Azure OpenAI resource, only those particular models will be available to you. Okay, so this is one thing that we need to keep in mind, that not all the models are available in all of the regions. There are only specific models as well as their capabilities which are available in each of the region. So it is a kind of an thing to think when we go ahead and create those Azure OpenAI resource, because based on what kind of an scenario that you want to solve for your business or for your customers, at the same time what kind of a models you want to make use, as well as what capabilities of those models you want to go ahead and use. Based on that, or based on the answers to those questions, you can go ahead and create that Azure OpenAI resource into those regions. So once you go ahead create that, we do have various models available, and from this portal only you will be able to see the models which are available under the Azure Open AI Studio. Okay, so you won't be able to see the models, for example, which are available from other providers, example Meta or Hugging Face or so on. So this is the simple kind of an interface wherein you will be able to only see the models which are available from the Azure portal itself. Okay, so that's the reason here you can see that we do have few versions of GPT 3.5, GPT 4 text embedding or the embedding models, as well as the Whisper, which is known for text to speech, speech to text kind of a thing. Okay, so these are the only models which are available. We do have column options here. So as I was talking, not all of the models are available in all of the regions. In the same way, the capabilities of those models also differ. So, for example, there are few models which are good at embeddings, few models which are good at completions. Maybe only few models or certain models can be fine-tuned. So, if you just select those options from here, wherever you will see that green tick, so that is the model which is capable of doing that particular functionality. So, from here you can see that there are only these three models and their versions which can be fine-tuned. The other models they cannot be fine-tuned. Same thing goes for the embeddings. So these are the models which are known for their embedding capabilities, which can be used for embedding to create your semantic indexes and all. So these are the capabilities that you will be able to see from here. Now that based on what capability of that model you want to use, you can select that model, and as you select the model, you just need to click deploy, and then you just need to name your deployment, select the deployment name, and select the model. Again, we do have a version. For example, if you want to have it auto updated to default, you can use that, so that you won't be able to, you don't want to go ahead and keep updating your model as there will be a new version. And again, you can select this TPM tokens per minute, which defines your threshold. So once you do that, once you click on create, there will be a deployment that is available. So once you go to this deployment, here you can see that I already have three models deployed, which I will be using for these demos. The only reason why I pre-deployed those models are like when you deploy the model, you need to wait at least 5 to 7 minutes in order to use those models. So that's the reason I have it pre-deployed. Again, for example, if you have your own data that you want to bring into the system for testing and training kind of a data sets, you can upload from here. So there are various capabilities available, and the main thing here is the playground. So here we do have two types of playground: completion as well as chat. So Chat Playground offers more capabilities because over there we can define the system message, which it defines the behavior for that particular model. For example, here you can see that we are simply talking that you are an AI assistant that helps people find information. Similarly, for example, if you are creating a model for a specific domain, then you can mention that you are an AI assistant who helps solve mathematical equations, or maybe who helps guiding people onto the medical issues and everything. So that is the system message which defines the behavior for your model. Then again, we do have certain prompts as well. So for example, you can define the user as well as the assistant role inputs. So it simply means that, for example, how we want this particular model to behave. So for example, for a certain question which is coming from user, how you want that particular model to respond. So those two things will come under user and assistant. So this is again known as to be a few shot kind of a learning for your model, so that you can direct your model to respond in a way that you want. Okay, so these are the few things that we have got here. Again, we do have a parameters here which will help us to define the behavior for this model. If you can lower down the temperature, it is going to give the realistic kind of an results. If you make it to large between 0 to 1, if you set it to 1 or higher, in that case it is going to give you maybe some kind of an phonetic results as well. So if in case you are writing some kind of an fancy story or maybe some fictitious kind of an things, in that case you can go for the temperature as one. If in case you want to stick to the data which is at the ground, you can just lower down that temperature. Top P again is on the same ground, so do experiment either with temperature or top P. Don't play around with both. Okay, so that is the general kind of a guidance. So all in all, this is how the Azure OpenAI Studio looks like. But now that, for example, when we want to go ahead and explore this Azure AI Studio, so we have got lot many capabilities. So the first question that we always get like, if there was a Azure OpenAI Studio, then why Microsoft had introduced another studio called as Azure AI Studio? So as I said, this Azure OpenAI Studio is pretty much limited to only be used with the Azure OpenAI resource. But when it comes to the Azure AI Studio, so this is how it looks like. So this Azure AI Studio is kind of an umbrella for all of the AI resources that we have got under the Microsoft Azure. So from here you will be able to make a connection to the other resources as well. So once you open up this Azure AI Studio, this is how it looks like. If I go to the top level, so here it starts with the hub. So hub is nothing but it is kind of an collection of all of the projects that you have got. So it provides you the collaboration kind of an environment for that projects, as well as from here you can define your data connections, security settings, quotas, all those kind of a thing. So here you can see that I have created one hub. So just in case you want to see how the hub looks like, so we have got hub that gets created under a subscription and a particular resource group. We need to specify the location for that as well, and then again we need to get it connected to the Azure AI service that we had created at the first point. The other thing here is like, optionally even you can create this Azure AI search, which is very much good known for all of the searching or the embedding kind of an capabilities. Okay, so if you can create those, it is going to help you for the semantic, vector, or even the hybrid kind of an searches. So once you create that, this is how the hub will look like. Again, creating the hub probably takes 5 to 7 minutes. So that's the reason I went ahead and pre-created those Azure AI Hub. Okay. So once we load that Azure AI Hub, this is how it looks like. And then inside of that AI Hub, we will be able to go ahead and create something called as projects. So there will be multiple projects that we can create under AI Hub. Okay, it's taking some time. Let me just try to refresh it. Probably it will be a bit faster after refresh, but okay. Right. So this is how it looks like. So you can create multiple projects under that. And again, this is where you will be able to see all of the connected resources. So you can just click on new connection, and then from here you will be able to connect to the other AI related services. Okay. So that is the beauty of having this Azure AI Studio. So from here you can connect to all those various resource types as well as the Azure AI models that you can see. So I already have made connections to the Azure AI Search as well as a couple of blob storages where probably we can store the files. Now that when we go inside of the projects, so this is a place where we will be able to create our deployments, evaluate them, and then again start moving from there. So here, if I go into the deployments, here you can see that we have this similar kind of a look and feel that we had got for the Azure Open AI Studio. But now that when I go to the deploy base model, here you can see that at least in the Azure OpenAI Studio, it was only limited to the Azure OpenAI models which are available. For example, GPT models which are available under the Azure OpenAI, as well as few of the embedding model. But now that, for example, if you have a capability of Azure AI Studio, from here we can have connection to various provider kind of an models, for example, including the ones which are available in Azure OpenAI itself, as well as the one which are available from Microsoft 5.3. So 5.3 is nothing but SLM, small language model that is being known for. Then again, we do have few models which are available from Llama, Meta, even there are few available from Mistral, Hugging Face, and many more. Okay, so these are the models that we will be able to use. So now that we can use those, but mostly again there is a confusion. Like now that we have got various or large set of models which are available, almost 1,714 models that we have got as of now under the East US2 kind of a region. So from here you can see that even if you are confused about which are the providers that we have got here, then we do have got Azure Open AI, Meta, Mistral, Nvidia, and many more. Okay, so these are all of the providers from where all those models are available. But the question is like, since we have too many models available, how we can select the best one? Okay, so in that case, probably you can come to this inference task where you will be able to select the capability that you want to do. So, for example, if you are interested in summarization of the email or maybe any of the document that you have got, if you are targeting that kind of a scenario, so you can just select that summarization, and then it will filter out all of the models which are best known for all that summarization kind of an capabilities. Okay, so you can do all those kind of a thing. At the same time, for example, if you want to compare those models side by side, as like for example, if you're purchasing a car, you do compare two models side by side based on various parameters. So similarly, we do have model benchmarks here. So once you go to that model benchmarks, this is the entire benchmark which is available to you, and even from here you can selectively choose few models. Let's say for example, Microsoft 5.2, if you want to compare that maybe side by side with could be Meta Llama 3. So in that case, you can just go ahead do that comparison. Probably that wasn't the best comparison, but probably you can go ahead and try to compare that with GPT 3.5 Turbo. Okay, so here you can see that it is creating the score or giving the score based on how they will behave. So obviously, GPT 3.5 was maybe available from very long time, and again 5.2 just got released, so it has got more capabilities. So in that case, here you will be able to see like how those two models behave side by side, and then you will be able to get to the decision like which one to go ahead with. Okay, so this is how it looks like. Again, once you create those models, choose the models, make the deployments. Even from here you can go to this chat playground, and from this chat playground we'll be able to evaluate those or maybe test out those models. So here you can see that I have selected GPT 3.5 Turbo 16K, as well as I do have GPT-4. So GPT-4 is very much well known for the multimodality. So that means you are not only limited to text in, text out kind of an functionality, but again, it can help you for multimodals, including audio, video, images, all those kind of a thing. Okay, so GPT-4 is well known for that. So this is how it looks like. But now that let's see how you can go ahead and even use something called as an function calling inside of this, because we know the basic capabilities. So let's say for example, if I ask this model to tell me a joke on cat, so it is going to go ahead and give me the response. Okay, so probably let's see like how good it is for everyone to be laughable. Okay, so it can go ahead and it can give you some kind of a joke. So this is nothing but the generative AI. So based on all of the content which is available already onto the internet, it is creating a new content. So that is the basic capability that we have got here. But now that we will move a bit further and see, like for example, if you want to create your own copilots, in that case, how you can use those concept of, for example, function calling semantic kernel, and then you will be able to build the enterprise ready kind of an applications. Okay, so with that, let's go for the function calling.
So the latest version of GPT-35 Turbo and GPT-4 are fine-tuned to work with the functions, and also they are able to both determine when and how a function should be called. So if one or more functions are included in your request, the model determines if any of the function should be called based on the context of that prompt. So when the model determines that a function should be called, it responds with a JSON object including the arguments for the function. Now let's go ahead and check in a depth how we can use this function calling with Azure Open AI service, how we can call the chat completion API with your functions and the user's input, how we can use the model response to call your APIs or function. Yeah, so this provides a native way for these models to formulate the API calls and the structured data outputs. So, all based on the functions you specify. So, it's important to note that while the models can generate these calls, it's up to you to execute them to ensuring you remain in a control. So, at a high level, you can break down working with functions into three steps. The first one is called the chat completion API with your functions and the user input. The second one, use the model response to call your API or function. And the last and third one, call the chat completions API again, including the response from your function to get a final response. Let's go ahead and check the demo.
All right. So now that we have basic understanding of function calling, but let's say, for example, just to give some more idea. So let's say, for example, we have got our model here. It could be any of the model, the one which supports function calling. And most of the time, people do get confused with this name called as function calling. So they do assume that there could be few Azure functions that we have got, and then this particular model that we have got here can go ahead and invoke those functions. Okay, so is it something like that? So no, it is not at all like that. It cannot call the Azure function as such, but it is able to call out any of the functionality. So it could be Azure function, or it could be anything else. So one quick example that I can take, like let's say, for example, we have an API, or maybe some kind of a third party API, or any of the REST API which can give us the weather, okay, or probably any of the API that can give us the capital of the country, or even there could be any API that can give us the temperature of the country. So now that, for example, if I ask any of the model, like what is the weather of the capital city of Japan? So this, I'm asking this question to my model, like what is the temperature of capital city of Japan? Okay, so that means my question has got two sets here. First thing, I want to know what is the capital of Japan. Second thing, I want to know what is the current weather of Tokyo, which is capital of Japan. So in that case, my model needs to be aware that, for example, if any of those kind of a question come when I want to know the capital and I want to know the weather, so there are few APIs available, or there are few endpoints which are available that it can rely on. Make a call to those endpoints, it can get the results. So similarly, we do have those two endpoints. Let's say we have got endpoint available for weather, we have endpoint available for getting the capital. So when we will ask this kind of a question, firstly it will go ahead, find out, use this API or use this functionality to go ahead and give us the output of what is the capital of Japan. So we will get the result as Tokyo. So what it will do is it will make another call because it knows that there is another API available here, or another function definition to be precise available here, which can give us the weather for that particular city. Okay, so it can pass on this city to this weather function definition. It can get the entire result back, and then it will again pass that to to our model. Model will generate the new generative AI on top of it, and it will give us the output. Okay, so this is how it works. Okay, all right. So with that, let's get into the demo and see how does it work. Again, I do have this code reference which is available onto this blog URL. Okay, so what we are going to do is, let's say, for example, if I go to the or ask any of the model about, let me just go there and let me ask like, what is the stock price of Contoso? Okay, so let us try to ask this question like, what is the stock price of Contoso? So Contoso is nothing but a fictitious kind of a company, and there it says that I'm sorry, but as an AI, I don't have real time access to the stock prices. Okay, so that means this is the gap that we can see into the AI, because it does not have information about the current current ongoing things into the live world. It has been trained, means all of this model has got some kind of a training date, and then obviously since we are looking at the live kind of an result, for example stock price or maybe weather, in that case it fails there, it won't be able to give you the response. So now that we want to fill out that gap and we want to make our model aware of those endpoints or maybe those function definitions which can help us get that information. Okay, so we will ask the same question to one of the application that we have built using this function calling, and let's say whether it is able to give us the response. So this is the application that I have got, which is created into .NET. So what I will do is I will just quickly run this application first, and then we will go to the code. So this is using Azure OpenAI itself. As you can see onto the code as well, we do have certain URLs, key, and everything. So this is nothing but the console application, and it will just work as a user assistant kind of a model. So it will ask me for the question that a user can go ahead and ask. So I'm giving the same question like, what is the stock price of Contoso, and then it will use that function calling, and here you can see that we got the output that the stock price of Contoso is 26.06 USD. Okay, so this is the output that we have got. But let's see like how it was able to get to this information. Okay, because there is no company called as a Contoso, but still we have mimicked that as an company, and then we are providing the result. Okay, so first thing, since we are using Azure OpenAI, we will be importing all of those components here. So let's say if I go into the packages which have been used here, so we are using certain packages to go ahead and use this. But probably for that, I already have mentioned that into my blog article. If in case I can just bring it to you. So this is how the function calling works. So this is our LLM, large language model. Whenever the user prompt will come, the we are just making LLM aware of all of the function definition. For example, getting the stock price, getting the weather, and everything. So there are n number of function definitions that this particular LLM is now aware of. When there is a situation that LLM fails to get the information, or it comes under the scenarios where it needs to know the current kind of information which it is not trained on, it will start looking for all those function definitions, and when it gets to that current or the correct kind of an function definition, it will process that function definition, get the result, and then that real time information will be again passed back to the LLM. It will again generate the response based on that, and it will pass the response back. Okay, so this is how it works. And then again, in this particular article, I have mentioned everything about what kind of a DLLs and everything that you will have to add. So obviously here we are using Azure.ai.openai kind of a NuGet package to go ahead and do all those magic. Okay, so this is the package that you can see here, Azure.ai.openai. So now that if I can again go back to the program.cs, so we are making an instance of this Azure OpenAI. We are passing it the OpenAI URL as well as the key. So this one you will be able to get it from your Azure portal. I'm going very basic, but let's say if you go to the your Azure portal where you have created this Azure OpenAI, you just need to click this endpoints from the overview sections, or even you can go to the keys and endpoint under the resource management. So this is nothing but your endpoint that you have got, and then this is the key. Okay, so key you always need to be securely stored, because combination of these two can help you get authenticated to this Azure OpenAI. Okay. All right. So this is what we are doing. So we do have this Azure OpenAI URL as well as the Azure OpenAI key. And then again, as I said, not all of the models they do support function calling, but GPT 3.5 Turbo 16K. So 16K is nothing but the capability of that model. So that means it can process the 16K tokens as an input and as an output. Okay, so this is the model which is capable of function calling. So what we are doing is like we do have this model to work on, and we are just making this model or this LLM as a function aware. So we are creating one function here called as stock price function, get stock price function. So this is the function that we have got.
I have
So
one
this is the
query. Hello.
yeah, go ahead.
So the model which we are using, right, 3.5. So if I use 4.0 or something, is there anything is difference is there?
No, not all of the models they do support function calling. As of now, I think there are only few which I had noted down here. So I guess only GPD 3.5 support and GPD 4. Okay, so GPD 4. These are the only two models that do support function calling.
Okay.
Nothing else.
So function calling is for the API call, or it's a kind of.
So it is only that we are making that model aware of certain functionality. So this is the kind of an information that we need to pass on. So there is a function definition. First thing is you need to have the name as well as the description, and this name and description being used as the NLP, natural language processing. So that's the reason when there is a question comes like I want to get the stock price, like I asked like what is the stock price of Contoso. So that's the reason it went into this NLP, natural language processing, and it came to know that okay there is a function definition available which can help me get the price of the stock. Okay, so this is entirely based on to the NLP, natural language processing. So again, for example, if you have used Microsoft 365 Copilot, even it is based on the same kind of an fundamentals. There again, we do have natural language processing. Based on that, we do get all those parameters. So again, here you can see that we are extracting out all of the parameters which are available. So when I say what is the stock price of Kuntosaw, so this NLP will help us extract the information from that prompt that I'm asking about the stock price of a company, and the name of that company is nothing but Contoso. And then it will be passed as a parameter for the further processing. Then what we do simply is that we do have one function called as get stock price. I'm not making any real time call here. I'm just using the random function to go ahead and mimic the stock price, but again here you can have the real world logic done to maybe query the stock exchange APIs and get the actual stock price, and then you can return it from here. So this is the function definition that we have got, and we are just making our LLM, large language model, which is GPT 3.5 Turbo 16K or maybe GPT 4, aware of that function. So whenever we will get a question around stock price, our LLM knows that okay, there is a function which is available or the function definition available there. It can go ahead and call that function. So whenever it goes ahead, we just need to see like what is the finish reason for that. So whenever it will make a call, so for example, if that status of that call is nothing but a function call, that means it is calling a function. Okay, so now that it needs to go ahead and call the function. So in that case, we again make sure that which function it is going to call, because we are the one who are making that LLM aware of the function. So that means we can check like then which is the function that is being called. Then for example, if we know that okay, stock price is the function which is being called now, we can get all the information about the prompt. So from here you can see that we are formulating all those parameters to be passed on to that function definition, and then we are simply calling the get stock price method. Okay, so this is the method that we just have implemented, which is the dummy, which is just a dummy method as of now. So we are just calling that function, and then we get the entire output from there. And once we get the output, we just process that output by calling the LLM again, because we just need to pass on that byte of information to the LLM, so that LLM can again process that information and generate the new content, because it is known for the generative AI. So it will do that and then it will give us the result. So not every time I'm running the or I'm giving the same kind of an input, I'm going to get the same result, because it is the generative AI. So even the text, the formatting of the text, it will differ. Okay. All right, so that was very quick about how we can use the function calling. So now that let's see, for example, if you want to use the OpenAI Assistant APIs, how you can do that.
So Assistant is a new feature of Azure OpenAI service is now available in public preview. So Assistant's API make it easier for the developers to create the applications with sophisticated copilot like the experiences that can shift through the data, suggest the solutions and automate the task. So previously building the custom AI assistants needed a heavy lifting even for the experienced developer, while the chat completions API is a lightweight, also it is a very powerful, so it's inherently stateless, which means that the developers had to manage the conversation state and chat threads, the tool integrations, retrieval documents, and the indexes and execute the code manually. So the assistant API as the stateful evolution of the chat completion API provides a solution for these challenges. So Assistance API supports the persistent automatically managed threads. So this means that as a developer, you no longer need to develop the conversation state management system and work around a model's context window constraint. So the Assistance API will automatically handle the optimizations to keep the thread below the max content window of your chosen model. So once you create a thread, you can simply append a new messages to it as user response. And the assistants can also access the multiple tools in a parallel if needed. And these tools include the code interpreter and the function calling. So let's go ahead and check all these assistance components in a detail. So the assistant, that is my custom AI that uses the Azure Open AI models in conjunction with the tools, and the threads, a conversation sessions between an assistant and a user. So the threads store the messages and automatically handle the truncation to feed the content into the model's context. A message created in an by an assistant or a user, so the messages can include the text, images and other files. So messages are stored as a list on the thread. So the activation of the assistant to being running based on the content of the thread. So the assistant uses its configuration and the thread's message to perform the task by calling the models and the tools. When it's come to the run steps, a detailed list of steps the assistant took as a part of run. An assistant can call the tools or create the messages during its run.
Okay, so now that, for example, if you want to go ahead and make use of assistant, there are at least few things that we need. First thing, name of the assistant, a simple name that we should give. For example, here you can see that we are calling it as a math assistant. The instruction, what kind of a functionality that assistant should do. The deployment, that means the model that we want to go ahead and use here. Function, for example, as we have seen, we can create those function definitions. So we want to make aware that assistant about those functions. For example, if there is any kind of a code that needs to be run for that, we can go ahead and use this code interpreter, which is out of the box functionality there. And then again, files. So for example, if you want to bring your own data in the form of files, you can use those as well. Okay, so with that, let's get into the demo and see how that looks like. So for that, again, I will go back to the Azure portal, and this kind of a functionality is available from both the portals. Even if in case you are using Azure Open AI Studio, we do have this assistant functionality here, and the screenshot was from this AI Studio itself, or Azure AI Studio itself. Again, for example, if you want to use it from the Azure AI Studio, even in that case, we do have assistant. So which is onto the left hand side. Here we do have assistant, and from here we'll be able to use. Right now it is still into the preview, but again you can use that. So let's say now that we just want to see how this assistant look like. So first thing that we want to do for this assistant is we just want to give it a name. So by default, whenever you will create assistant, let me go ahead and create a new assistant. It will have some kind of a name, just a name called as assistant and then some random number. So this is the name as well as this is the ID that you can see here. So if you want, you can go ahead and change this name, but ID is auto generated. You won't be able to change that. So this one can be used, for example, if you want to do something programmatically. Okay, so now that let's say, for example, we want to create some kind of an assistant which is helpful for solving the maths kind of an equation. So in that case, we can just call it as a probably maths assistant. We can rename this. Okay, I will just call it as a maths assistant. And then again in the prompt under the instructions, um, I will mention that you are an AI assistant that helps solve complex mathematical equations. Okay, so this is how I'm instructing that particular assistant to behave as an mathematical expert. Again, we do have certain tools here. So these are the two tools which we were talking about. For example, if you want to bring your own data um, into the system or into this assistant playground, you can turn on this or toggle on this file search, and then from here you will be able to add your files. Now that for this particular demonstration, we are turning on this code interpreter. So as soon as you turn on this code interpreter, you will get the power of running the Python code, and then again even you will be able to see that. So there will be a container that one will be created in the background, a Python container where all of the instructions that you are running, if needed, it can run on top of that. Okay, so now that as we have turned it on, you can see that we will be able to go ahead and use this. But again, for some reason, you want to go ahead and add functions as we had discussed. You can also give the definitions here. So these are few of the examples. For example, get weather, get stock price. So these are nothing but just the function definitions to make your assistant aware of that there are functions that can be called if needed. So for this demo, we are just making the code interpreter on, and then this is the thread that we were talking about. So here you can see that we have got a unique thread ID that got created for this particular run. Okay, so right now we are into this run and we have got this ID generated for this thread. So I will go ahead and I will ask this assistant, like I need to solve the equation 3x plus 11 equal to 14. So can you help me? Okay, so probably you can guess it uh, before it runs. So it is starting to giving the response. And for example, if I just keep pausing here, you can see that it is running that code interpreter. So this is the thing which I was talking about, that it will go ahead and it will run that code onto the Python container. And again, here you can see that it has given us the output called as x. The value of x is 1. Okay, so that was very small kind of an example. But let's say, for example, if you don't trust and we want to see like what is the exact code that this particular Python code interpreter has run into the background. So for that, we can just run or ask this assistant like show me the code you ran to get to the solution, and it can go ahead and it can give you the entire code that it has run onto this container or this code interpreter to come to this conclusion. Okay, so here you can see that this is the entire code which is which was running into the background for this. Okay, so again, this was a very quick demonstration of the assistant API. So you
And
can
this code
use
is
the
this code interpreter is giving some example. The code is right. So is that we have written or it's from the chat GPT directly?
no, this code interpreter is just the Python. Whenever you will turn on this code interpreter, it will
Okay.
be just the Python container that will get created for you. But it is
Okay.
the ChatGPT who will run that code inside of this code interpreter. Okay,
Okay. So
so
and whatever the
yeah,
code you have shown in the C sharp, right? So you have uploaded here anything here or
no.
okay.
Yeah,
Okay.
so that was only for the that was even the just the console application, even not a web application.
Okay.
So that code is
So could you
not
please
added here.
yeah, could you please ask one more question here? So is that solution
Sure.
is correct? Just ask, is the solution is correct, whatever you providing? Yeah, like that.
Is this solution correct? This is what you want to
Yeah,
ask?
is the solution is correct? Yeah.
Sure. Let us go ahead. Wow,
Yes. Okay.
it is confident. Okay.
Okay. So now I just want to ask you,
And
so
for example,
how
if
it is
you see here,
recognizing the my previous command and how it is maintaining the state, preserve the old conversation, and then it is giving the answer. How it is happening? Is anything the settings we are doing here?
no, that's the reason in the introduction we said like the assistant API has got the capability that it can maintain the state. So, for
Mhm.
example, if you
But
just
in
go
code
into the
level, how
chat
we are going to
playground,
bring? So let's say I want to create a chatbot for for my organization or one of the things. So I want to build. So how it's going to be done in the code level? So I'm just asking, is there any way? So because this is the UI thing, but we are not going to
correct?
use this
Yeah.
UI, right?
So,
We are
right.
not
So
going to
at the
use.
top here, you can see we do have view code. Okay. So you can just click this view code, and then you do have a capability to use this in a Python or into a C sharp as well. Okay. So you can use this code as it is into the C sharp or even into the Python, and then you're good to go. So if you copy
Okay.
this code as it is, it is going to run.
Okay. Go to the
Okay.
TypeScript. TypeScript.
There is a JSON, C sharp, curl, no TypeScript.
Oh, okay.
So for example, if you want to do it using TypeScript, then there is Azure OpenAI npm package available. So you just need to, at least it does support completion API and chat completion API. If you just need to check whether does it support assistant APIs. If in case yes, in that case you can use that as well. So if
Where
you
I
want,
don't
I
know.
do.
Where I yeah. Where I
Yeah.
have to check for the TypeScript. Yeah.
So TypeScript you won't be able to see here, but again I do have few examples here. Um, for
Yeah.
example, let me just check
Yeah, I have
one
seen your
here.
example. Yeah, I have seen your example for the TypeScript. I have used also, but the thing is, in the TypeScript, we don't have any of the things to using the state, maintaining the state.
No, you don't
We,
need to maintain the state because the state will be maintained by the assistant API.
but the thing is, we need to enable the assistant API, right? So how we are going to enable the assistant API? It's in preview, okay? No,
Enable.
I tried with the TypeScript, and I didn't mention any of the stateless to preserve, but the thing is, still it's not working. I'm just so maybe after this call, maybe we'll connect, maybe we'll discuss because I don't want waste other time. So we can just continue the same thing, and then we'll discuss after this call
Sure,
the
sure,
code session.
perfect.
Okay? Yeah,
Yeah, all right, thank you.
yeah.
All right, so this is what we have got for the OpenAI Assistant API. So now that let's move to the very last part of the session, which is the semantic kernel. We'll see like how the power of Copilot stack that we can bring into the picture, and then we'll be able to create this kind of a semantic kernel based Copilots.
So, Semantic Kernel is an open source SDK that lets you easily build agents that can call your existing code. As a highly extensible SDK, you can use the Semantic Kernel with the models from OpenAI, Azure OpenAI, Hugging Face, and more. So, by combining your existing C Sharp, Python, and Java code with these models, you can build the agents that answer the questions and automate the process. So, to help the developers build their own Copilot experiences on top of AI plugins, Microsoft have released the Semantic Kernel. It is a lightweight open source SDK that allows you to orchestrate the plugins, that is your existing code with AI. So, with the Semantic Kernel, you can leverage the same AI orchestration pattern that power the Microsoft Copilots in your own app. So, why use an SDK like a semantic kernel? So, today's AI models can easily generate the messages and images for user. While this is very helpful when building a simple chat app, and it is not enough to build a fully automated AI agents that can automate the business processes and empower users to archive more. So, to do so, we would need a framework that can take the responses from these models and use them to call the existing code to actually do something productive. So, semantic kernel makes the AI development extensible, so it has been engineered to easy to add your existing code to your AI agent with plugins. So with plugins, you can give your agents the ability to interact with the real world by calling your existing apps and the services. So in this way, plugins are like the arms and hands of your AI app. So additionally, semantic kernel interface allowing it to flexibility generate any AI service. So this is done with a set of connectors that make it easy to add the memories and AI models. So in this way, semantic kernel is able to add a simulated brain to your app that you can use easily, swipe out as newer and better AI models becomes the available. So the next list is these AI plugins in semantic kernel. So the plugins are the fundamental building blocks of semantic kernel, and also with plugins you can encapsulate the capabilities into a single unit of the functionality that can then be run by the kernel. So the plugins can consist of the both native code and the request to AI services via the prompt. Let's go ahead and check for the demo.
All right, so now that we are coming to this last demo, so this is a semantic kernel that we are building for booking kind of an application. Okay, so this is the code which is available onto the Microsoft GitHub repository. So I'm going to use the same code. So let me just um, open up the portal, go to the Microsoft 365 or the portal.office.com, and from here booking is one of the app which is available as like the other apps. So inside of the Microsoft 365 we do have various apps including Microsoft Teams, SharePoint, and similarly we have got another app here called as booking which help us to maintain the bookings for any of the users. So let's say for example you want to book a time or anything else, we do have those this app called as in bookings. So here I already have created one booking page. So from here you can create a booking page. Okay, so onto this site or onto this link you will be able to create a booking page. I already have it created one called as hotel booking. So I will just open up that and this is how it will look like. And what happens generally is from here you can just click on new booking and then you will be able to book a table for your hotel and everything. Okay, so this is the kind of a thing that we have got and we are trying to achieve that through semantic kernel. Okay, so for that again let me go to the Visual Studio where I do have everything. So let me just run this first and then we will go through the code. Okay, so again this is nothing but kind of a simulator which will help us to book the booking that we have seen into the booking app, and then again it will help us to list out the booking as well as delete the booking, everything that we need. Okay, so firstly it is asking user like what does it want to do. So I will say like please book a restaurant for me, and then based on the training that we have given to it, it will ask like it needs to know name of the restaurant, again date and time of the booking, number of people in the party, and name, email, and phone number for the reservation. So I will say like I would like to book a table at a restaurant called as the French Laundry on the 27th of July, that is tomorrow at 7 p.m. for four people. My name is John Doe, and my email address is this, and my phone number is this. Okay, so it has accepted that booking, and it is asking me just for the confirmation that do you want to book a table at this restaurant on this date and time for four people. So if I say yes now, it is going to go ahead and do the booking. Okay, all right, so just trust me that it does the booking. But okay, even in case now that you want to see like where that booking is, let me just again come back, let me just do a refresh of this page, and then we should be able to see that again. Here I'm just playing bit around with the UTC date time format. That's the reason probably you will not be able to see it here, but based on the UTC timing, it goes on to the 28th of the July, and then again it does that. Okay, so probably one more thing that I forgot here to add the 24th of July 2024, because I've seen that when I was running this demo, probably even it was taking some random uh, years as well. Okay, so again we will go ahead and ask please book a restaurant for me. Again it will ask for the same details, and this time I will include the 27th July 2024 to be specific, and I will ask that go ahead and do this booking for me. It will again ask me for the confirmation. Let us say yes here, and it should do that booking. Okay, right. Okay, so let us go ahead, try to refresh these bookings, and because now that we are pretty much specific that on 2024 itself we want to do that booking. Okay, so now that you can see that this booking is here, it has booked 4 seat at the restaurant called as the French Laundry. Okay. Okay. Now that let's say for example, we just want to go ahead and also check about the current bookings that I have got here. Again, I can go back to this application and I will ask like list my current bookings. So it will list out all of the bookings that I have done so far. So this is the booking that probably went into 27th of July 2022. Okay, as I said, since I wasn't specifically mentioning about the year, it has just randomly taken some year and it did the booking in the past. Okay, because it is not yet fully developed model. Okay, so let's say for example, if you want to go ahead and cancel out any of the booking, we can just say like cancel my booking. Oh, and then it will ask me for the ID of that booking and everything, and it will do the cancellation. Okay, so right now it is going to the current booking that I have done, and then it has just given the message that okay, it is canceling the current reservation which I just did onto the 2022. Okay, and it has deleted that entry. So this is the basic kind of an example that we have here for the booking, but again a full-fledged kind of an example that you will be able to go ahead and use for your bookings. Okay, so how does it work? So first thing to get it work, we do have something called as an as you ready app registration, or even nowadays we just call it as Microsoft Entra ID app registrations. Okay, so this is the app registration that we have got. Let me just show it to you the app registration as well. So once you go into the Microsoft Entra ID or your Azure AD, here you should be able to see all those enterprise application or the app registration. So let me go to the app registration, and I do have app registration here called as booking service. Okay, so this is the booking service app registration that I'm using in my code to talk to this booking application using the Graph APIs. So once you go to the manage, we do have API permissions, and in this API permissions here you can see that we do have the specific API permission called as bookings booking appointments dot read write dot all, and with this API permission, graph API permission, we are able to make those calls for booking to read from the booking apps as well as write to the booking apps, and this one is running with the application permission. Okay, so now that let's say for example, let us go into the code to see how does it look like. So we are storing all the information about this app registration into the app settings.js, and then simply we do have appointment.cs kind of an what we say model here, which simply talks about the how the appointment looks like. So appointment has got start date, the name of the restaurant, party size, and the reservation ID. Then we do have this app config.cs to read all of the configurations from this app settings.json file to get to all of the settings that we have got from to read from this file and
Is
use in our
this,
code.
yeah, I have one doubt. This is calling Graph API.
This is called Graph API.
Okay.
So this is the Graph API which I'm specifically pointing out. I'm using this booking appointments.readwrite.all. Okay.
Okay.
So if I again go back to the code, so this is nothing but this is just one-to-one mapping between the app settings.json versus the code that we have got into this class. Okay, now that we have this booking plugin, which is a plugin which we were talking about when we had a look at the architecture of semantic kernel. So this is the connector that we have got, which acts as a brain for our model. So again here we have got the same things, like whenever the user will ask that they want to book the table, at least we want to make sure that we have sufficient information in place. For example, name of the restaurant, time, the number of users, the customer name, email address, and phone number. And for example, if they do not provide, we go ahead and ask them. Once we have that information, we make the confirmation by asking them whether they want to do the yes or no. So that's the reason here you must have seen that it was every time asking yes or no whenever I went for the registration or the booking. So whenever I say yes, then only it goes ahead and do the registration or the bookings. So for the booking, again, we do have this booking appointment. So this is nothing but the graph API call. So this is how the graph API or the payload for that particular graph call has to be done. So that's the reason we have got all that payload created here. And then once we create that, we just call this graph client and then do the booking. Okay, so this will just go ahead, call the API to go ahead and do the booking. Second thing, let's say for example, when we want to list out all of the bookings, again we make use of the graph client, and again we just give specifically like what is the business ID. That means the ID of the booking that we had created, and then we get all of the bookings under that ID, and we return that back to the user. When user wants to cancel the reservation, again we just accept the appointment ID or maybe the restaurant or date or time or maybe the party size so that we can cancel it out. And then again, since we have the read write kind of a permission onto the graph client, we can simply go ahead and make a delete call on top of it so that the booking will get deleted. So this is the connector that we have got, which act as a brain for our semantic kernel. So how we use it? Firstly, like instead of this main, when this function run, it reads everything from that app config. Then second thing is it goes ahead and get the token so that we can get connected to the graph service client. And then again, the same thing that even you have observed into the function calling to make your model aware of all of the functionalities. So here we are just creating the kernel, we are preparing the kernel, and then again we are making it aware of few of the plugins that we have got, and that plugin is nothing but the booking service plugin, and we are just passing out the booking business ID and booking service ID. So whenever we will make a call onto this graph client, it knows which object to work with. Right. So then after we are making aware of this chat history. Okay, so probably this is a question or maybe answer to the question which you were talking about, how we can maintain that chat history. So here we are creating entirely as a chat history, and that's the reason it knows that okay, this is the chat history with which I'm doing all those transactions for this booking. So I'm maintaining that as a chat history. So we'll go ahead, create the chat history from here. We will ask the first question to the user what he or she want to do, and then we will add that user input. For example, the first question that I asked, like I want to make a booking, okay? So that we will add to the chat history. So this is the first instance of the chat that I initiated. Then secondly, it will go ahead and do that function calling kind of a thing. Okay, so it is kind of an we are enabling that auto function calling. So whenever it thinks that there has to be a function call, it can go ahead and make that function call. So we are just making it aware. As soon as we get the response back from the function call or maybe from the model itself, we just again add that back to the chat completion API as a chat history. And then from there, the conversation continues. Again, we ask the assistant to go ahead, put out that as a result. So as a result, all of the output that we get into this void, which is from the LLM, which we are putting here, and again adding that to the chat history. So whenever we will continue with the same conversation, it will have the reference of the chat history, like what I did, and then it will be able to do it from here. And again, until unless user wants to stop this, we will just continue. Okay, right now this is running into the while true, and yeah, that's it. So this is how it works. So this is kind of an application which will help you to create those kind of semantic kernels which can have that copilot kind of capabilities through which you will be able to build the applications on top of Microsoft 365 as well as maybe any of the other application that you are running. All right. Okay, so I guess we are well over the time, but this is the demos that I just wanted to make you aware. So we got introduced to the Azure OpenAI service, then we saw like how we can make the deployments, how we can work with the chat as well as the completion API. Then secondly, for example, when needed, how we can go ahead and use the function calling so that we can make our models aware of the function definitions and whenever needed, they can use it. We extended on the same concept and we saw like how we can use this kind of an capability of semantic kernel so that even using the semantic kernel, we can add some kind of a brain to our model and then using those connectors, it will be able to communicate. All right. Okay, so with that, that was all we wanted to cover for this session. So thank you very much for joining us here. These are our LinkedIn as well as blogs as well as Twitter. So feel free to get in touch with us for any further discussion. With that, again, I want to make a thank you to the organizer of this, especially to Bhargav. Thank you for giving us this opportunity, and thank you everyone for joining us on Friday evening. Okay, hopefully this session was helpful to you.
It was really helpful only. So, but we have some QA session if you are making,
Yeah, yeah,
then
sure,
that
sure.
will
Please,
be good.
please.
Yeah.
Yeah, yeah. Please go ahead.
Now it's fine, huh? Okay. Um,
Prabhakaran, I'll just switch off the recording. So, yeah,
Yeah,
but yeah, before I do that, Nanddeep and Smita, really thank you for
thank you. Yeah.
making this happen. And yeah, we'll talk again. Yeah. So just
yeah.
you can
Sure. Thank you. Thank
stop
you very
the
much.
recording.
Yeah, you can. Yeah, you can. Yeah.